Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is lecture number 12 in chemical kinetics. Okay, in last lecture I was explaining you about the integration rate law of first order. Okay, now we'll see numerical based on integration rate law of first order. Okay, so here the reaction is hydrolysis of methyl acetate in presence of HCl. The reaction gives CH3COOH plus CH3OH. And we have to prove that this reaction is of first order. How will you prove it? Okay. So, the data is given to you like this one, that T is the second time and volume of NaOH is given, which is used for titration. Okay. So, at 0 time, the time required or volume of NaOH is 9.62 ml. After 75 seconds, at 75 seconds, the volume required of NaOH is 12.10 ml. Then at 119 seconds, the volume of NaOH required is 13.10. Then at 183 seconds, the volume of NaOH required is 14.75 ml. And at infinite time, the volume required of NaOH is 21.05 ml. Normally, this reaction required 3 hours only, but we will keep this reaction in a bottle for 3 days and 3 nights, and after 3 days and 3 nights, we will take the final reading. As it is in the equilibrium state after 3 hours, so even after 3 days and 3 nights, it will be in equilibrium state only, and there is no change in concentration of reactants or products. So the reading after 3 days and 3 nights is called reading of infinite time. Okay, now prove that the above reaction is of first order. So we have to prove that this reaction is of first order. Okay, we have this information with us. Okay, now when time is 0, answer, when t is equal to 0, at that time, at 0 time, means when we mix ester and water on HCl, there is only ester, HCl and water, nothing else, because at 0 time reaction is not proceeding and therefore there will be no product. Okay, then we pipette out fixed volume of mixture and it is titrated against NaOH, which is filled in burette using phenolphthalein as an indicator. Now you know that the reaction mixture contains only ester, water and HCl, and this mixture is titrated against NaOH. So the reaction will be like this: ester plus HCl, which react with NaOH from burette. So definitely NaOH is base and it will react with only acid HCl, and therefore we will get NaCl plus H2O plus ester, because ester is not going to react with NaOH. So it is basically acid base titration, and in this case the volume of NaOH required to neutralize only HCl. In the beginning, only HCl is neutralized by NaOH, and this reading of NaOH is known as V0, and that is initial reading, first reading. So it is called V0 because it is required only for HCl. Okay. Then suppose we take reading after 3 days and 3 nights. That time will be infinite time. Okay. That is called final reading. So final reading is taken after 3 days and 3 nights, which is called the reading at infinite time. At that time, obviously, uh, uh, the mixture contain ester plus HCl. HCl is catalyst, so that remains the same. Then acetic acid, because it is a product, and methanol. Now this mixture is titrated against NaOH using phenolphthalein. Obviously, NaOH react with only acid, that is HCl and CH3COOH. So the products are NaCl plus CH3COO Na, sodium acetate, plus H2O, plus ester and methanol remain unaffected. That means NaOH is utilized for titration of HCl as well as acetic acid, and therefore this reading will be maximum, because at that time, at infinite time, the amount of acid will be maximum. So at T infinity to at T is equal to infinite time, the amount of CH3COOH in the mixture will be maximum, and therefore this reading will be maximum. Okay, so the volume of NaOH required at infinite time, at T is equal to infinite time, is equal to V infinitive, and this is the maximum reading, and this is called maximum reading. Okay, or final reading, which is always having maximum value. Okay, similarly, we can take reading at any particular time. For example, it is given at 75 seconds. Okay, so when we want to take reading at 75 seconds, the mixture contains ester plus HCl plus small amount of acetic acid and small amount of methanol. Now this mixture is titrated against NaOH, which is in a burette, using phenolphthalein as an indicator. Again at 75 seconds also, there will be small amount of acetic acid and HCl. So this will react with NaOH and form NaCl plus sodium acetate. But the amount of sodium hydroxide required for this titration will be greater than V is 0 but less than V infinity. Okay, so volume required, NaOH required for this one, for this mixture, is called V75, and this will be greater than V0 and less than V infinity. Okay, so this way we got V75 reading. Okay, so from, if you subtract V75 and V0, we will get X. Okay, and if you subtract V infinity and V0, we will get small a, that is initial amount of ester utilized for the reaction. Okay, so this way we can find out X and A for any particular condition. We can take reading after 119 second, we can take reading after what is given in the table, that is after 183 second also. Okay, and then now we will make a table. So small a is equal to V infinity minus V0, and V75 minus V0 is X at T is equal to 75. Similarly, V119 minus V0 will be also X, but at time 119 second. Okay, so this way we will make a table of this. First column will be time in second, and that is 75, 119 and 183. Okay, so small a at 75 will be 11.43. This is also 11.43, and here also 11.43 because small a remains same. Okay, X for that is V75 minus V0, then all readings are given. So here it will be 2.48. You can try this way. Okay, that is 12.1 minus 9.62, that is 2.48. Then at 119, this will be 3.48, which is 13.1 minus 9.62, and for 183 it is 14.75 minus 9.62, that is 5.13. Okay, then we have to find out a minus x. A minus x is difference of these two, which will be 8.95, then 7.95 and 6.3. Then we have to find out k, and k is equal to 2.303 upon t log a upon a minus x. Okay, so for first one, the answer will be 0.003259. For second, it will be 0.003264, and for third it will be 0.003254. So then we have to take average of all this thing, and that is constant. And you can see that K1, this is called K1, this is called K2, and this is called K3. And for this you can say that K1 is equal to K2 is equal to K3, and therefore it will be of first order. Okay, so when we find out K1 is equal to K2 is equal to K3, then we can say that the reaction follow first order. Okay, so this way, if all constants are constant, then it will be related to particular order of reaction. So the reaction follow the first order. Okay, so this way we prove that the reaction is of first order. Hydrolysis of ester, because we take excess amount of water, the hydrolysis of ester is always first order reaction. Okay, so this is one of the numerical which is based on integration rate law of first order. Thank you so much.